A certain brand of cookies sells many cookies in packs of 5 and has determined a probability distribution for the number of cookies that they sell in a given day. Use the data to answer the following questions. You may round to 2 decimal places if necessary. What is the probability of selling 15 mini cookies in a given day? Well, if we had been asked for the probability of selling 10 mini cookies in a given day, then all we would have to have done is read off the probability associated with that value. But in the case of 15, that probability is missing, so we have to come up with some means of determining it. In order to find that missing probability, one thing that we know for all probability distributions is that the sum of all the probabilities in a distribution has to be equal to 1. So if we add up all the probabilities that we have so far, taking care to just leave a variable, perhaps x, for the missing probability, then the sum of all those numbers has to be equal to 1. So far, we have something that we can add some of the numbers together. So 0.12 plus 0.05 plus 0.38 plus 0.17. That gives me a sum of 0.72 so far. So 0.72 plus the missing value is equal to 1. So in order to determine the value of the missing value, what I need to do is just a little bit of algebra to get the variable by itself and take 1 minus 0.72, which is the sum of the probabilities we have so far, and that would give me 0.28. So that is the probability of selling 15 mini cookies in a single day. So I think I'll add that to my distribution. Find the expected number of mini cookies sold in a day using the discrete probability distribution. So the expected number, the expected value of a probability distribution, is equal to its mean. So effectively what we're being asked to do is to find the mean of this distribution. In order to do that, we will take advantage of the calculator using OneVarsStats. And I have grouped data, and I need to input all the data into 2 separate lists, the values of the random variable x into L1, and the probabilities into L2. And of course, if you have information already in your tables, go ahead and delete that out first before getting started. So the value of my random variables are these, and my associated probabilities is this set of number here. Now, if I take the function OneVarsStats and include L1, L2 at the end of that, then what will happen is it will take into consideration that I want weighted statistics and give me a weighted mean, which is what the expected value is, a weighted mean. So 11.65. Find the variance of the number of mini cookies sold in a day using the discrete probability distribution. So the variance, the standard deviation is sigma, and the calculator does give us a value for that. In fact, it's 5.876 and a little bit additional to that. But that's not the variance. The variance is that number squared. Now, one thing we can do is we can take the value listed and we could just type in 5.876 and square it. But the more decimal places that we have in this calculation, the more accurate of an answer we're going to get. So another way you could do it is to, if you hit the Vars key, The Vars key gives you variables within the calculator. So it's just memory locations where everything in the calculator is stored. Under the statistics, all of the output to each of the functions that we run are stored here. So there is a variable for sigma x, which is the population standard deviation. If you call up that variable and then hit the square key, it'll give you the answer to as many decimal places of accuracy as it can. And the only reason I mention that is because the homework system tries to make sure it will allow as many possible varieties of correct answers as it can. But sometimes errors like these are a little bit difficult to judge because when you're squaring numbers, it's very sensitive to how many decimals you use. So you always want to use as many as possible. And then you can round your final answer to however many decimals are required, which is generally 2 for variance and standard deviation. So 34.53 it looks like.